Hi there, and welcome to Mini Math Lessons with Karen. So this lesson is on introducing translations or transformations, rigid transformations to students. So this is just an exploration type of lesson where we're going to explore what is a translation, what are some properties, and hopefully the students through their exploration can come up to with their own conclusions and definitions. So again, the link to this free activity is in the description of the video, and all you do, post it up here into your browser, and it'll bring up the lesson. And so you, your students, anyone can use this link and work on the activity. However, unless you have an account in Classpad.net, your work won't be saved. So if you want to save your work, modify the lesson to make it fit your needs a little bit better, make sure you've created an account in Classpad.net. Very easy to do, also free, and then you can save everything. So here's the activity. So first we kind of talk about transformation. What is a transformation? We're going to be exploring this specific type of transformation called a translation. But what is a transformation in general? So by reading this, going through this, they're basically getting the idea that a transformation changes something about a shape. It might be its size, might be its location, might be its direction, whether it's going counterclockwise with the points or clockwise, those types of things. So then they come down and we're going to start to actually explore a very specific type called a translation. And in this particular activity, or this first section, so there's two parts to this activity, we're going to be looking at a vector translation, and then we're going to, a little bit later, be looking at rules, so where you're going horizontal and vertical. So we're going to do both. So basically the idea is you'll notice there's a lot of questions here, and there's a place for your students to write their answers and their observations. It's really about playing and observing. So the first thing we're going to do is, okay, so here's this original shape, A, B, C, D, and here's this translated image of the original, so pre-image, image, so we've got some vocabulary in here as well, and here's this vector. And so they're asked to basically just play around and kind of make some noticing. So they can move the vector. What does that do? Well, it moves the image, and the closer we get the vector to our original, the smaller the vector is, and the more the image overlaps onto it. And so then they're asked, can you make the image A prime, B prime, C prime, D prime line up exactly? And so what happens to the vector? Well, notice the vector basically becomes a point. And so then it's just different kinds of explorations. Can you make it go on the other side? So hopefully they're noticing things like the length of the vector determines how far away the image is from its original pre-image. The direction kind of controls where the image ends up. So all of these things are things we want them noticing and that they're going to observe and write down. Once they've done that a little bit, then we have some more specific things that we're going to do. So over here we have some hide show buttons that are going to be asked to, click on sides. What do you notice? Move things around. So hopefully by the end of this, they're going to notice that, no matter how we change the shape or the vector, the corresponding sides seem to have the same length. And so then the same thing with angles. We're going to notice, oh, well, that's interesting. The angles that correspond have the same measure. And that's sort of where we're trying to get them to go, that a translation moves an object, slides it somewhere, up, down, left, right, however you want to think about it with the vector. But it doesn't change the shape and it doesn't change the size. And it also doesn't change the orientation. A, B, C, D is still A prime, B prime, C prime, D prime. They're both counterclockwise. And then we have them explore an interesting thing. So this is the distance between corresponding points and also the distance of the vector. And what we want them to figure out is, oh, well, that vector determines how far apart all the corresponding points are in the image and the pre-image. And so the vector really kind of controls that movement. So this is where we're hoping that they will end up at the end of this first exploration. And they've kind of written everything down here as they moved along, and there's questions to guide them. Then we go into this next section, which now instead of a vector, we actually have a rule, a translation rule. And it's controlled by sliders. So there's an H slider that moves horizontally and a V slider that moves vertically. And so they're going to explore this. So if I move my vector, let's move my vertical vector down, what happens to my shape? So then they start exploring, what do these vectors do? How does that connect to this translation? So the translation rule is telling you basically what direction to go in and how far to go in. So how far up or down, how far left or right, those types of things. So that's what they're going to discover here. And then we have, and if you'll notice, there's a little note here. It says all the things you discovered in this first activity up above are still true here. We're just adding on to this. So this is just some additional properties. And so you'll see that they'll have this, the distance from one point to its corresponding image point, and how does this compare to the sliders and the translation rules. So lots of discovery here when you think about rules. And so they're again writing their observations here. And after they go through all of this, the last thing they're going to do is take all the things you observed and noticed about translations and describe a translation. Basically define what you think a translation is based on your observation. So hopefully they're going to come up with their own definition for translation. And then there's a challenge here because we talk about what is a rigid transformation. Translation is considered one. If the word rigid means not able to be forced out of shape or bend, why is a translation considered a rigid transformation? So kind of connecting things, because in the future lessons we're going to be working with coordinates and finding rigid transformation moves. So this is just a precursor to that. So lots of exploration here, lots of moving and dragging and comparing that we hopefully then will have students be able to come up with their own definition of what a translation is.